Hi, my name is Matt Noyes,
I'm Joe Rice.
I'm Anthony Castillo.
and this is Lab 6.
The two main important concepts in this lab include the Faraday Effects and the stress optic effect.
The Faraday Effect, also known as the magneto-optical effect, is an interaction between light and a magnetic field. This interaction between light and the magnetic field rotates the plane of polarization. The strength of this rotation is proportional to the magnetic field and the Faraday constant. The Faraday constant is a property of the material in which the light is passing through. The next important concept in this lab was the stress optic effect. Stress optic effect is a stress-induced birefringence of a material that can change the retardance of the slow and fast axes, depending on the force applied to a crystal.
There are several key concepts worth learning about in this lab because they apply to the real world. The first of these concepts is the concept of a Faraday Rotator. This is important because it allows us to construct optical isolators, which essentially act as diodes for the light, allowing it to only go in one direction. This is especially helpful in fields such as optical communications. The reason that the Faraday Rotator acts the way it does is the concept of non-reciprocality, which is also very important here, as light is basically the plane of polarization is changed the same way regardless of the direction of propagation of the electromagnetic wave through the Faraday Rotator. Another key concept of this lab is the stress optic effect. It's important because it allows us to examine birefringence, which is common, especially in optics made of plastic, where stress applied changes how the light is polarized.
The first of our most significant results were the Faraday constants found in this lab. Most notably, it was found that the max extinction angle method was almost 30% closer than the return fixed intensity method for calculating these values. The second most significant result of this lab was the calculation of the stress optic coefficient, which describes the birefringence induced by the stress applied on the crystal.
These results compared pretty well with my prior knowledge, particularly the Faraday Rotator. I expected it to operate in the way it did. I hadn't seen stress coefficients tested like this, so that was cool.
One thing I liked about this lab was the Faraday Rotator. Although the setup didn't work that well, it did rotate the polarization in a way that I would expect. One thing we didn't like was the fact that the glass rod didn't have a plastic sheath, so it wasn't centered in our Faraday Rotator, which made our results kind of janky.